Hello, in this podcast we're looking at pesticides and we have two objectives. The first one is to describe the impact of pesticides on the environment, and the second one is to describe how pesticides can be used sustainably. First, we need a few definitions. First one is a pest. A pest is a species that interferes with humans and human welfare. So a pest will reduce the availability, quality, or value of resources. It can also be annoying. And of the millions of species in the world, only about 100 of them are pests. So most of the insects that you see out there, almost all of them are not pests. Now a pesticide, that is a chemical that's used to kill or control pests. And there are several different kinds, and here are the names of those kinds. And side, by the way, means that it kills. So a pesticide kills pests. So a fungicide kills fungi. An herbicide kills herbs or weeds. Insecticide kills insects. And rodenticides will kill rodents, and particularly rats and mice. Of the pesticides, there are two groups that we need to be concerned with right here. One is called a broad-spectrum agent, and those are toxic to pests and non-pest species. And an example of that would be something like DDT, which we covered in a toxicology podcast. There are also narrow-spectrum or selective agents, and these are effective only against a small group of species. So broad-spectrum agent would affect things beyond what you want to affect, and narrow-spectrum would only affect those that you want to affect. So in terms of what affects the environment, in terms of negative effects, most people would prefer to use narrow spectrum. Now some of the things that you need to know we've already covered in the toxicology chapter and in the podcast, and you still are responsible for it, but I'm not going to cover them really in this podcast because it would take up time, and I'm just repeating myself, and you just go back to that podcast or that chapter to review it. So you are responsible for knowing who Rachel Carson is and what she did. You need to know about DDT. You need to know about the term of bioaccumulation. Also, you have to know about persistence. And one additional thing I want to include here is that when it comes to using pesticides, farmers tend to have a choice between using persistent pesticides, which tend to be less toxic, but they can bioaccumulate higher on the trophic levels, and also between non-persistent pesticides, which will break down quickly and not bioaccumulate, but they're also very highly toxic, not just to other species, but also to our own species. Now here's why we use pesticides. They are a rapid and easy response to pest infestation. So for example, say in your home, all of a sudden you notice that you've got a problem with mice or a problem with ants or cockroaches. You just call the exterminator, they come, apply the pesticides, and hopefully that can take care of the problem. When you use pesticides, it results in a higher crop yield because the reason why it results in higher crop yield is because the pesticides aren't eating the crop, so you end up with more crops surviving. It's also not only used in agriculture. It's a quarter of the pesticides are in the United States. They're also used in houses. They're used in gardens, lawns, parks, playing fields, swim pools, and golf courses. For example, we've had problems with mice in our school, and we have problems with mice in my own classroom, and we have put out mice traps, which attract the mice, and the mice gets caught on the glue structure on there, and then they have to remove the mice, and then they have to kill it because they can't just set it free because the mice will come back. In our homes, actually, we use the pesticides more than the pesticides are used in the farms. An average lawn is sprayed with 10 times more pesticides per acre than farmland, and I believe that golf courses use more pesticides actually than the average lawn. Here are the advantages to using pesticides. One is that they save human lives. Like as bad as we said in that earlier podcast about how DDT is, the fact is that the person who synthesized DDT, Paul Mueller, he won the Nobel Prize for Medicine, and very rightly so, because DDT has saved thousands and thousands of lives, because it has killed insects that carry diseases. DDT has killed mosquitoes that carry malaria, and thanks to DDT, malaria is no longer a problem here in the United States. If you go to the Museum of Natural History, you'll find there a very large model of a mosquito. The reason why that model of a mosquito is there is it was part of an exhibit explaining malaria, and for that exhibit, lines went around the block. The reason why I went around the block was because at that time, malaria was infesting New York City. Doesn't anymore, thanks to DDT. Also, as I said before, that pesticides help increase food supplies because so much of our crops aren't destroyed because the pesticide kills the pests. But even with that, more than half the crop is still lost to pests. Also, pesticides, they work fast when you apply them because they will kill the pests very quickly. They also have a long shelf life and they're very easily applied. When they're used properly, the health risks are low relative to their benefits. Also, the newer pesticides tend to be safer and more effective than the older ones. The reason why is because the newer ones tend to be derived from the natural plant chemicals. That tends to make them safer for the environment. And also, with genetic engineering, we're producing pest-resistant crops, so instead of having to spray the pesticides onto the plants have the pesticides inside of them, so only the things that will eat the plants will be affected by the pesticide. There are also some disadvantages. One is that it accelerates genetic resistance to pesticides. So when the chemists develop a new pesticide, they apply it, and then within 5 to 10 years, resistance appears, and then pesticide becomes less and less effective, and that will lead to the chemist producing more new pesticides. And this is called a pesticide treadmill, where every decade or so we have to come up with brand new pesticides to replace old ones which the insects have become resistant to. Also, some insecticides will kill the predators and parasites. So this means that in some cases, applying an insecticide will have the bizarre result of actually increasing the number of pests, because what will happen is you spray it, that kills the pests, it also kills their predators and parasites, but then the eggs that are, say, inside of the plants aren't sprayed, so the eggs survive, and then when the eggs hatch, the pests then emerge, and there are no predators around to eat the pests, so the pest population starts zooming up. Also, pesticides can travel and they can pollute, because very, very little of the sprayed pesticides reach the target pests, so it ends up going in the water, gets sprayed into the ground, and so it will reach other things besides what you want it to reach. And that ends up harming the environment. So every year, pesticides can destroy 20% of honeybee colonies, 67 million birds, and 6 to 14 million fish in the U.S. And this can have profound implications, as this video shows.
Southern Sichuan Province. In the rural county of Hanyuan, pears are the local calling. Pear orchards carpet the mountains down to the foot of the valley. And in the center of town, the pear goddess bestows an eternal blessing on the yearly harvests. It seems to work. Hanyuan produces 80% of the pears in the region. Each year in August, the trees hang heavy with fruit, individually wrapped before harvest to protect it from insects. A typical family will harvest around 5 tons of pears. But it isn't bees farmers have to thank for the abundant crop. The bees here disappeared long ago. In the early 1980s, uncontrolled use of pesticides wiped out the local bee population and killed off the pollinating plants that feed them. Fruit production plummeted, and local farmers watched their livelihood vanish before their eyes.
I wrote a letter to Beijing, and they wrote back and said, You have to hand pollinate, because the insects used to do it, but they've been killed off by pesticides. So now, you have to do it.
Now, each year in April, farmers must play the role of honeybee. And it's not as easy as the bees make it look. They start by collecting and preparing the pollen by hand. They scrub the anthers, the male part of the flower, for their pollen, and dry it for up to 2 days. When the pollen is ready, the human pollinators go to work. Dr. Tang Ya from Sichuan University has been studying the pollination process used by farmers in Hanyuan. Today, he has come to see the fruits of their labor.
When I first heard about this, I didn't believe it. This is work normally done by nature, by bees.
With nothing more than a stick of bamboo and some chicken feathers, farmer Cao Xingyuan conjures up the fuzzy body of a bee. With a dip of pollen, a light touch is just enough to pollinate the blossoms. Every spring, hundreds of workers take to the trees and pollinate the pear flowers, blossom by blossom. A hive of bees can pollinate up to 3 million flowers in a single day. A human can only pollinate up to 30 trees. It's a painstaking and expensive substitute for a service that bees once provided for free.
I wish it would go back to the natural state. I wish the bees would come back, because this is a really difficult situation for us.
To replace honeybees with human pollinators in the United States would cost more than $90 billion a year. And even here, in Hanyuan, hand pollination may not be sustainable for long.
For the farmers doing hand pollination, it's still feasible. But now, China is changing very fast. Most of the young people are heading to the city. I think in not such a long time, 10 to 20 years, hand pollination will be very difficult.
Hanyuan's story provides a glimpse into a frightening future without bees, and a reminder of how irreplaceable the honeybee really is.
There's no artificial substitute for pollination, nor is there any concerted effort to even develop one. People have tried here and there to find substitutes for animal pollinators, wind machines and certain sorts of vibrating devices for greenhouse use, but nothing works like a bee.
Also, some pesticides can harm people, because every year pesticides can poison 3 million agricultural workers worldwide and also kill 20,000 to 40,000 people worldwide. And in the United States, 250,000 people become ill because of using pesticides in the households. U.S. laws, unfortunately, have not been all that effective. Pesticides are regulated by the FDA, the EPA, and the USDA. And the main law that affects them is FIFRA, which is the Federal Insecticide, Fungicide, and Rodenticide Act of 1947. It was amended in 1972. And while the EPA is supposed to evaluate the health risks, less than 10% have been evaluated. EPA says because they have no money. And I talked about this in the toxicology podcast. I won't go more into this now. Even with all these problems, 64 pesticides, including DDT, have been banned or severely restricted. In 1996, the Food Quality Protection Act was passed, that requires the EPA to reduce allowed levels of pesticide residues in food by a factor of 10 when information is not known about its effect on children. Now, the circle of poison, or the boomerang effect, sort of goes around the ban that we have on those 64 pesticides, because we do have laws that restrict using those, but those laws don't restrict exporting them. So these pesticides are produced here. They are shipped out to other countries, which then use it in their farms, and then their produce, which has these persistent organic pollutants, these POPs, are then sent here. We buy them, and it has those pests. But there are treaties that ban the use of these, and also to have the informed consent of the importing countries. But the United States has not signed these treaties. Now, there are some alternatives to pesticides. One is crop rotation, and that will keep the numbers of specialist pests down, because the numbers will go up. Say if you have corn and they specialize in corn, but then if the following year that field doesn't have corn, then the numbers of those corn specialists will then go down because they don't have any food. Also, you can provide homes for the pest enemies. One way is to use a polyculture, where there are many different species in the field, and that'll provide homes for the pests. Also, in the margins of the fields, if there are other plants there, or in between the rows, if there are other plants growing there too, that can provide homes for the carnivores. And in your own home, if you keep the grass no lower than 3 inches, then that will make the grass more competitive against the weeds like crabgrass. Also, the plants are genetically engineered to resist the pests, either by having the pesticides or in some other way that will prevent us from having to spray. Also, using a biological control, where you bring in the pest's natural enemies, and those natural enemies, like say a wasp or ladybugs, will then eat the pests. Of course, if you use a biological control, that will not completely wipe them out, but it will keep the numbers down to an acceptable level. Also, you can use insect pheromones or perfumes, and this will only affect one species, and it can lure them into traps where that will then kill the insects. Also, you can use hormones to disrupt the insect life cycle, where you apply it at the right time, and that would, say, prevent the insects from reaching maturity, where they just simply, say, won't pupate, or they won't leave the pupal stage to become an adult. But it has to be applied at exactly the right time, and since many insects use the same hormones, it could affect other species. And another alternative is just simply spray them with boiling hot water, and that will kill the insect. Another alternative is something called Integrated Pest Management, or IPM. And here it uses a lot of these different things together, where each crop and pest are all evaluated as part of an ecosystem, and the objective is to reduce the damage to a tolerable level. And here the farmer really has to know his or her farm, because he or she has to look at the farm very closely. First thing they do is they use biological methods and cultivation controls like crop rotation and using biological controls to control the pests. And they need to realize that there is going to be some pest damage, and there are going to be pests there, but they have to measure it to see at what level will yields start going down. And when the yields start going down to unacceptable levels, and they realize that biological cultivation methods don't work, then they start using narrow spectrum pesticides to bring the levels down, even back down to the manageable levels. So this takes more time, it requires expert knowledge, and it's being used in the developing world. It's also being used here in the United States, though here in the United States its use is hindered by the pesticide industry because it uses fewer pesticides. Now we come to our concluding questions. Number 1, which receives more pesticide, a golf course or cornfield? Number 2, List 2 advantages to pesticide use. Number 3, list 2 disadvantages to pesticide use. Number 4, what is the circle of poison? Number 5, what is IPM? That concludes this podcast, and I'll see you in class tomorrow.